So welcome to volume. Most people are thinking that they know what volume is. Like, oh yeah, I remember volume. That's when you find like volume of the inside of an object, the space that the object has on the inside of it. You're absolutely right. That's what it is. And I'm betting that most people right now are thinking to themselves, oh, I remember sixth grade or fifth grade or whatever it was last year. And I'm thinking, oh yeah, that's length times width times height. Well, yes, it is. That's going to work for one shape and one shape only. That's a rectangular prism. But we're going to take it a little bit deeper than that in this lesson. So I need you to tune in, pay attention, take down some notes. Pencil and paper is great, but I would probably recommend pausing the video along the way and maybe using Google Keep to jot down a few notes. When you're done with this video, there'll be a couple of PDFs you can look over for some more notes to jot down some things in Google Keep if you need to. But really, this should make things pretty clear. And then there'll be some practice. And then after this practice, you can work to the highest score you can. You can email me with questions. You can join us for the 1:30 meetings to ask more questions and get some clarification. And then at the very end, there's the optional math puzzle. And I announced the 5 winners. We're going to look for one winner this time, randomly selected. But this time I chose to announce all 5 as a winner. So here we go. First of all, before we get to volume, what'd you do about surface area? So remember, there's a big difference between surface area and volume, and it's going to be up to you to decide, is the question asking for surface area or volume? So SA was surface area, and it was the area of all the surfaces. No big deal there. So we learned that in the surface area, there was 2 main formulas to memorize. 2 main formulas to memorize, and here they were. So for all prisms, we found that the surface area was double the base, so double the area of the base, and that capital B stands for area of the base. So we had 2 of those, plus the lateral area, and the lateral area was the wraparound stuff. And when we did that, it found the surface area of all prisms. Just like this formula finds the area or the surface area of all pyramids. Now, in your Flipgrid assignments, some of you mixed up the words surface area and area. So surface area is going to be used more for like pyramids and prisms and 3-dimensional objects, things that have multiple surfaces. If you're finding the area of a pentagon or the area of a hexagon, you don't need to call it the surface area, just the area of the hexagon or the area of a pentagon or the area of a triangle. Okay, so overall, we did pretty good with our Flipgrids. Some of you still need to get your Flipgrid assignment in. If your Flipgrid assignment is not turned in yet, it's worth 18 points. You're going to want to get that in order to get the completion points and then get the passing grade and all that good stuff. So please see me if you have any questions about that. All right, so let's move on. Volume. Again, you're going to memorize just 2 formulas, kind of like surface area. Memorize just 2 formulas, and yes, you must memorize them. So let's talk about what they are and how they come about. Before we do that, let's take a look at this. How would you find the volume of this regular prism? So this is a triangular base, and I'm going to kind of use my cursor here to show you. It's a purple or pinkish color, and it's a base, okay? It's this tall, so the altitude, okay, they call that the height. So this yellow piece kind of shows how tall it is. And you could do this line segment right here, or this edge, okay? This is called an edge, and this would be the height of our prism because it's got a triangle at the bottom, and it's got a triangular base at the top. So this would be called a triangular prism. Now, with that said, we're not going to worry about lateral edges, lateral faces, altitudes as much. We want to worry about this. There's a base, and then there's a height. And if I can find the space that that pink piece takes up right there, if I can find the area of that triangle, all I really want to do is multiply it by how tall is the altitude. It's like an elevator ride from the top down to the bottom, or from this triangle right here at the bottom all the way to the top. And then it's going to find all the volume on the inside. So we're going to start off with the area of the base and then multiply by how tall is the actual prism. So what about all these prisms? It's the same idea. So let's take a look. You can see here, if I found the area of this red triangle, I could take it on an elevator ride to the top, and it would match up with this triangle at the top. And then it's found all the space throughout the inside of this prism, just like I could find this red triangle in the front and take an elevator ride to the back, and it meets up with this triangle right here. So really, it's finding the area of this red triangle, which we call the base, or the area of the base, and then we multiply it right there. It is times h. So times h. So times this height right here. And it's as simple as that. Like down here, another good example. You're going to find like basically there's one row. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 cubes in this row. So if it's only one level high, this would be 12 cubic units. And remember, volume is always going to be in cubic units. So if I then said, well, what if this was 2 high? Well, then it would be 24 cubic units. If this measured 3 high, it'd be 36 cubic units. If this measured 4 high, it'd be 48 cubic units. If it measured 5 high, it'd be 60 cubic units, and so forth. So the point is, you're looking for one layer at the bottom, and then once you know the area of the floor, okay, you're going to multiply it by how tall does it get to the top? So how many layers will it take to completely fill in the prism? Just like this one. This is where you guys keep thinking, oh, it's length times width times height. Well, watch. If I do the length, which is 6, times the width, which is 3, you're right. You're then going to multiply it by 4 to get to the answer, and that's the volume. But that's the same thing as just finding the base. 3 times 6, that's 18. That is the area of the base. That is this gray space right here. And if you can find that gray space, that is the area of the base. Once you find 18 for that floor, then all we need to do is multiply it by this 4 right here, which is the height of our prism. So when you hear things like length times width times height, well, that's true. It's only going to work, though, for the rectangles on the floor, or a rectangular prism, or maybe even a cube for that matter. But here's the deal. You find the area of any base, whatever that base is, and then just multiply it by the height. And yes, that's why that works. Same thing over here. You can see it. Right there it is. Volume is equal to, there's your V, equals area of the base times the height. All right, so let's move on. You're still going to need to know all these common shapes. There's no doubt about that. You'll still need to know squares, rectangles, triangles, circles. Okay, that kind of stuff is pretty common. Make sure you know your 2D shapes pretty quickly, pretty easily, because it's going to help you along the way. So, volume of a prism. I've already explained. It's super simple. Find the area of the base. If the base is a square, use a square. If it's a triangle, use a triangle. If it's a circle, use the circle formula. So, let's take a look at how that looks kind of in using this GeoGebra site. So I'm going to kind of give you a really cool visual for that. So here we are on a GeoGebra site, which you can look up yourself. It's also linked in this presentation, and you're going to have access to this presentation real easily just by going into the folder to get it. I'm going to bring our screen up. I'm going to shorten this down to 1. I'll maybe bring the length down to, let's say, 5, or yeah, 5 is good. So now it's 5 by 10. And if it's a 5 by 10 base, it'd be 5 by 10 on the floor, which is 50. And then I'd multiply it by 1, and there'd just be one layer of 5 by 10. And if there's one layer of 5 by 10, you can see right here, the volume is 50 units, because it's going to be, again, right here, volume is equal to area of the base times the height. So area of the base times the height. Yes, they took the length and the width and made it become the base. But again, it's the same thing, area of the base times the height. So as this gets bigger, this goes to 2, well then my height doubled, and so did my volume, became 2. As my height goes up to 3, well, now I've got 3 layers of 50. 3 layers of 50 is 150 cubic units. And as I go to 4 or 5 or 6 or 7 or 8 or 9 or even 10, now I'm up to 500 cubic units. Because in this case, 5 times 10 is 50. That 50 times 10, which is how tall my prism is now, is worth 500 cubic units. And that little 3 right there means it's 3-dimensional. The units are 3-dimensional, so we call them cubic units because cubes are 3-dimensional as well. All right, so back to my presentation. And let's go to the next slide. So there it is, the volume of all prisms and cylinders. It's that simple. The volume is equal to the area of the base, which is the capital B right here, area of the base times the height of the prism. That's all you got to know. Perfect. But what if it doesn't come to another shape at the top? Like if it's not a triangle to a triangle, or a circle to a circle, or a square to a square, or a rectangle to a rectangle. What if it's not a prism? Okay, well, the volume can't be the same if it comes to a point like a pyramid or a cone. That's a true statement, but it's still pretty easy. So check this out. All right, so here we go. What if we found the base here, and then we multiplied by, let's say, the height? Well, clearly we'd have all this empty space that we aren't accounting for. So if it comes to a point, it's going to have less volume, and that should make a lot of sense. But the question is, how much less volume will it have? And there's a lot of math that we're going to be able to show and prove, and I'll do a video myself later on, but there's one coming up here in a moment that's going to prove it pretty well. The thing is, guys, it's right here. It is always going to be 1/3 the amount of volume if it comes to a point. So it's the area of the base times the height, and then you can either divide that by 3, which is going to work right here, or this is a really good way to do it too. The volume is equal to 1/3 area of the base times the height. It's just 1/3 the volume. So let's, for example, let's do this. If you took this blue triangle right here, it's a triangular base. What you would do first is you would find the area of the blue triangle. And the area of the blue triangle would be whatever it is. I don't even know because this picture doesn't actually have any dimensions. But then you'd multiply it by the height. And if you multiplied it by the height, you'd basically be taking that blue triangle all the way up this pole, and then it would make another blue triangle at the top, and it finds all the space inside of that triangular prism. But it's not a prism, it's a pyramid. And because it's a pyramid, it's only going to take up 1/3 of the amount of space. So we'd use this formula and just take our answer, divide it by 3, or take the answer and multiply it by 1/3. That's all you have to do. So here's a cool example for that. I'm going to jump over to GeoGebra one more time. And you're going to see here that you can divide a cube into pyramids. And it's a pretty cool little demonstration. So I'm going to start by taking this, and it says divide the cube, even with the extra E there. And it says divide the cube, or with the E instead of an I. So drag the slider to the right. So we're going to swing, watch this, ding, 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 down. And you can see what happens is in this cube, if it does come to a point, okay, like there's a point right there, and there's a point right there, and there's a point right there. And let's say I find the volume of this. Well, it's going to be 1/3 of whatever that cube would have been, because you can see 1, 2, 3 blue sections. It takes 3 blue sections of things that come to a point like this to fill the cube. Okay, there's pyramids, and then it takes 3 of those to collapse and fill in to that cube. Now that's one visual, but let's get to another visual. Here it is, the big formula. Volume equals 1/3 area of the base times the height. As I said earlier, if you didn't want to do 1/3 times the base, area of the base times the height, you could just do base times height, area of the base times height, and then divide it by 3, and that would be okay too. But here we go. Check this out. So they have the same area of the base. And you can see that they're the same height. So both have the same area of the base and they're the same height. So stop now for a moment and think. I'm going to go back to that video, but stop now and think for a moment. How many of those pyramids will it take to fill that cube? There's one. There's 2. Try to be as precise as possible. So that's pretty good proof right there, folks. It is 3. You can even see them here. 1, 2, and 3's back there. 3 square pyramids. 3 square pyramids have the same volume as that cube. So let's summarize what we've learned. It's really that simple. These are the 2 formulas you're going to memorize for volume. The volume is equal to the area of the base times the height for all prisms or things that have 2 bases, just like we did in surface area land. Now, if it comes to a point like the pyramids and the cones, memorize this formula. And that's it. It's really not that hard, huh? So hopefully you understood this pretty well. In the presentation, you can come back to this presentation. You can go through it by yourself. You can take a look at it. You can click on a face to submit how you feel about it, or you can click on this link right here. But I'm going to also have that same link within the folder. So I just want to know how you feel about volume so far, because that was kind of a crash course, but that's really just that simple. You got to find the bases, find the area of the base, multiply by how tall it is. If it comes to a point, divide it by 3 or multiply by 1/3. It really doesn't get any easier than that. There's a lot of practice. Please do your best in the practice. Please give yourself a good chance maybe at that puzzle. We had a lot of people playing the puzzle. 5 seconds for 2 minutes of AI1. We're glad to win it for this week's puzzle. And I really can't thank you enough for paying attention, working hard. Some people do have missing work out there still. You're missing a fifth grade assignment, get the fifth grade assignment turned in. You're missing a 2.6 test, get that turned in. You're missing an 8.6 test, get that turned in. Now's a good day to go check your grades, look the grades, look the missing things. I'll start reaching out to people that have missing scores, both your parents and your email accounts. Please continue to check your email every day.